Uh, Hello and welcome to this new session where we take a look at improving the font rendering. And so this is basically where we left off the last time. We had this application where we could just sorry. Debug, example debug. So we had this application where we basically had a picture of a cat, and then there are a few issues, such as the cat's RGBA model is not correct, but we have all of these other fonts. So we hover over the cat, we get more and more rectangles up here at the top. So still have a long way to go, but it's promising. So yeah, cool. So what we want to do today is basically the same thing, but for fonts. And so instead of showing rectangles, we want to actually show these node type label with the text format and the number, or which label this actually is. So we already have the parsing, so we know that the font size of this should be 15 pixels, and the font family is Webly Sleek GUI, which we will add here. So here's the font, here are the bytes of the font, here's the actual font. So more or less this is the same thing that we did yesterday with the images. It's exactly the same. Exactly the same thing. So first what we're going to do is we're going to fix the image display. We did some magic to make it work for a render image format, but here we say RGBA8, BGAR-A8. So what we want to say is, so it's really BRGA and not I hope this function exists, otherwise we're gonna have a bad time. So to this function does not exist, but the question is, how does lim do this? If we look at, how the image, how is this done? It does a lot of complicated things. I mean, it wouldn't be that hard to write our own function to convert to BRGA. Right. What I don't understand is why it only accepts BRGA. YUV. Maybe it's better to YUV to YUV. No, it does not have any kind of. Okay, this is just great. Let's see what we get. We have the examples, right? We have the image, right? We have the image widget from image, new image source, bundle trust. Probably, maybe it's even wrong. So just to confirm that, I just want to see if this is actually wrong. We can also rust, right? This is another web render based UI system where it's basically, yeah, it's, this one has the actual colorful logo, because I don't think that Lem is doing it correctly. So did you really, oh my god, you really put everything into one file. Maybe image, oh, macros query, image, no, image. So he has to build a, I mean, he has to build a image format. Right, here we go. RGB8. Oh, there is an image format. Image RGB8. So there is an image format when we go to the let's see what kind of image format do we have. We have R8, RGBA, F32 and RG8. But we don't have an RGB8. I just ask someone, maybe they know a solution. Right, I hope someone can answer this. So we just work on the fonts for now. Right, it's not really wonder how he's doing this. Render source lib.rs. Image key, image descriptor, order image, border image. Update image is the entry. Image descriptor. Image format. What kind of image format? Oh, you see, this is the problem with global imports. You don't know where the image format is actually coming from. Here's web render everything, web render API everything, which is completely redundant. Like, see, this is awful. But anyway, stride image descriptor. Can we build this from our own? Need to extend image format. How the hell? How the hell image descriptor? If we look at the image descriptor format, means it wants an image format, but RGB8? isn't... Sorry if this doesn't make sense to you, but ICBCR. So someone just told me that there is no image format for only BRGA8 because of driver problems, because some drivers seem to be very buggy about RGBA images, so we are basically forced to convert it ourselves. So it was used in WebRender, which is why this code that I just showed you, it uses an older version of WebRender, but since there were driver problems, we basically have to convert this ourselves. So yeah, so I think DirectX 11 doesn't support RGB8. We converted to BRGA. Right. This is okay. So he just linked me to this page, is how actually Servo does this. So this is this is great. This is exactly what I was looking for. Bytes in chunks 3, extend from slice, BRG8 pixels. Luma 8. Yeah, this is great. For external images, but not images in... So he just basically, this is a bit boring, so I asked him, okay, this is, you know, mainly the standard image format, so I asked him, you can support it if there's a good, but neither again for 2 channel, why you accept external images. Images. Yeah, but this is basically what we need. Well, it's better than crashing, so... G8 image Luma A8 Luma A8. I think this is what we need. Right, so this should now work way better than... We should basically fix the image. Not sure why... So yeah, now the image works correctly, but I'll wait for him to reply, just so we know that's... I'm sorry, this stream is pretty boring. I'll see in a few minutes, but basically, so what he says is that pixels for bytes.chunks3 pixels extend from size. There's actually an exact chunks iterator, but to 1, which means that we would have to do this all over again, BRGA8 pixels 4. So RG8 assumed to be very rare, and since having them in a separate texture would break drawing batches, probably better to convert it to BRGA8. well, okay, I think we got our answer. We BGR in bytes. Pixels dot extend from a slice BGR where's the chunks 2 BGR 0 BGR 0 and then BGR 1. Grayscale alpha. Shouldn't assert anything here because times 4. BRGA8 BGRA8. So this should basically okay, so So let's just, yeah, so the stylish code will probably crash if there's a driver that doesn't work correctly. It's always difficult to see if, right, to string lossy, yeah, error get image, blah blah blah. This is, yeah, this is why it's so important to just ask people about this, because I wouldn't have known what the reason is, because, you know, I don't work on server, but just make, before I forget it, I mean, it's just a small thing, but I think I can just fork this and just fix this small mistake I just saw there. I mean, it's not a large thing, so it's just it's not a large thing, just that you know, we can actually allocate this with the capacity of the image and image thing, which will not do any harm largely, but we need to have four bytes and pre-multiply. Not sure how this is going to work, if we even need this pre-multiply function. So it seems like there's a general, oh god, GitHub is bugging out, Git is bugging out, anyway. So I'm sorry we had this intervention, but, well, it's working now, isn't it? Right. We now go to development. Fixed image rendering for B, and oh yeah. So, yeah, image pre-multiply. We don't need to pre-multiply if we already have, because we already say, okay, it's going to be pre-multiplied, so we only need to pre-multiply if it's actually this format. So if the most efficient format is, of course, grayscale, but yeah, it seems that this conversion usually happens inside the driver for DirectX 11 images, so, and it's better to convert everything to BLGA8 so that the GPU batcher can then see, okay, it's this is all one image format, so we can batch them together in one draw core and not switch any shaders. you know, it takes a little while to upload, but I mean, how often are you uploading an image, right? It only happens at the startup, and then otherwise you'd be paying the cost for literally every frame. So yeah, I'm sorry, this wasn't really helpful, was it? So yeah. But it's interesting to see, because I mean, I wouldn't have known that RGBA 8 images don't work on DirectX 11. You know, I wouldn't have known it. I mean, they surely work, but they don't work as well. And they need multiple shaders and so on and so forth. So now we have every this is basically all I wanted to address, is just to make this development and then web render, so that we can just say, okay, where was this? Source YAML frame reader, web render, source YAML frame reader, YAML, oh, wrench, of course, wrench, source YAML frame reader, and line number 401. Right. So we can just say RGBA 8 BRGA 8. Where's this premultiply function called? This is only called here, RGBA 8 pixels.smute slice. Wait a minute. RGBA 8. So we only need to say, okay, we have this so we don't need this, do we? So we don't need to do it every time. Or 8 image.raw pixels. Okay, this is the same. Here we have premultiply, and the premultiply function apparently already swizzles the things around. If we look at the premultiply function, which is here, a pixels 3 2 1 0, a b g l a 8. So this so this already converts from BRGA 8 to RGBA. So here RGB and 0, yes, this is basically white. So grayscale alpha, and then we have premultiply pre-multiply U32 from maybe this isn't necessary. So, but the debug render code doesn't do this. It just, I mean, yeah, we don't need to pre-multiply if the format is, I mean, this does literally nothing because, you know, RGB, BRG, you know, it was them around, but this doesn't do anything. So all we need to do is say instead of saying like new, we can say like with capacity image dims.0 times image dims.1 . Isn't it? Right. And this pre-multiply function, use pre-multiply range no as pre-multiply function. Yeah, it doesn't allocate anything. This is literally the only change that is made. Oh, and we need to know 001. So if we know build and test, then we can just make this small change and just, you know, so I mean, I'm really grateful that they already have this framework because, you know, I wouldn't have known any of this. So, I'm currently very tired. I'm not streaming that long. But now that we fixed images, basically, we need to what I want to say is add font, add adding the font can take, I mean, you know, prepare image. This is called from the display list code. Where does this come from? Prepare image. Update resources. Update images. Uploaded. Ready for upload. Add image. Resources dot resources. Okay. I just want to say how long does this take? Read to end. Load from memory with format. Prepare image. Done, and then we want to say okay. We want to say time equals time indent now. Time 1. We want to say okay, time 2. When we want to say time 2 minus time 1. How long did this actually take to upload? Because this is what actually kills the performance. So how does this work in release mode? Can we actually use wrench directly? Probably not. Because, you know, why am I copying all this code from wrench if I can use it directly? But waiting on the git checkouts. Great. Oh hell no. Does this actually yeah, this is one of the things that I wanted to go about. It seems like the I think it's called renderer kind, right? If we have a window and we have a OS Mesa, renderer new, unwrap, notifier, new, unwrap. I mean, yeah, now we have this image, right? But we wanted to see how fast this is. So 0.6 seconds. 0.6 seconds to upload an image. 0.6 seconds. Yeah, I mean, you're not doing this too often. I mean, you know, uploading an image, it should be done in, if you're loading a level or something like this. But I mean, it does add decoding the image. It's a fairly large image, right? So it's not too bad. But it does it before the first draw call. Actually, this is interesting. I mean, probably people forgive if there's 1 or 2 seconds delay in startup, so better not use images directly. Or maybe we can make this asynchronous later on. But yeah, we should definitely, if there's no OpenGL, we should use the renderer kind native. If this actually works, renderer kind. Mesa. Wait, what? Yeah, we can just say this renderer kind native. If I say native, probably because ops native enable render on scroll false. Yes, because we don't need to render on scroll. Ops native mode ops was Mesa ops native clone ops was Mesa renderer kind. So then we can say ops or else native and Yeah, we can say here that we can say unwrap, but not in the other. But not in the rest of the code. Yes. Render kind. Web render. So here we go, up to native dot clone. It does not have the clone function. So great. Clear color. Just look at, no, oh, this was a pretty stupid function. Pretty stupid question. Device pixel ratio. Some so clear color. Get inner side pixel. This is basically, here we can say unwrap, because this will basically never fail. What is the yeah, this is basically cleanup stuff that I wanted to do. So render upload method. I'm just color F, option color F. And then we can just say, yeah, we already have color F. Window create error from the third bound window create from renderer error. Yes, okay, window create error. So if we don't when from web render, what does renderer new GL. What error does renderer new give us? Renderer new reserve self renderer error. Where is the window? Renderer error. So need this. We don't. We can actually just, we don't need to. So there's a lot of waiting today, a lot of waiting. It's not as nice as yesterday where we had all the fun stuff. We could add all the images. And yeah, one thing that I should do is to put all of the tests in a separate module, so I can say so that they are not compiled on every single compilation, so that they don't impact the performance of what we're doing. Just so that we can say, okay, we are testing all of this, but we currently ID tree also has some tests down here. Test. Tests. I don't know. There are people who do these kinds of tests in separate modules. So just to be sure, I will just say window OS Mesa. So just to be sure, I will just compile it just to see what it looks like, right? Oh yeah, and I should put this image. Where was this? Resources. Yes, I should. So now just to test the software rendering capabilities. You know, the cool stuff is that it just does the software rendering out of the box. You know, there isn't any no, there isn't any weird problems going on. Yeah, it does actually work. It actually uses OS Mesa, and of course the draw times are awful compared to, but I mean, you know, this is software rendering and we just switched it over in one or two clicks. So I'm actually impressed. And yeah. And I also removed the tests, yes. I always have to look this up, how git create branch b yes. Just in case. No. Git add web render. Use a pre-allocated for Right now we should have so we can compare and pull request. So that's basically, yeah, we now have software rendering. Cool. So the next thing is, of course, to add the font. Resources, add the font, which is more or less the same thing, right? Use font. Occupied, okay, none. Right. Font state, image type, we don't need this. Font state, which is basically the same thing as the image state, right? So we have the image state, and we have the, so is this font state. Uploaded. Then we have the font image info. Key and descriptor. I'm not sure if this is font key. Is there actually a font descriptor? Push font. No, not push font. Okay. Well. Font info, font data. font descriptor. There is no font descriptor, so we just say we just have the font data, and then we have the font info. And yeah, font state. Use app render font key. Font key, font state. Yes, font info. Font data. Is there no font data? No form data. Font key. Right. ABI font key. Mode, add image, data. Where do we have this fast hash map font size? Add font. Okay, here we need to have multiple fonts. Fonts are really quite challenging, which is why I wanted to do images first and then fonts, because with fonts we have one piece of data, but then we can choose different kinds of fonts and we need to mix and match. And yeah, this is why is this also font error? Yeah, this is kind of awful. Use font, font state, font error. Font state. Image format. Where is our font error? I can't find the font data. Debug partial eq. Should be the... Oh, come on. Oh, whatever. At least debug. Yes, okay. Yes, we need to font data. Only the data for the fonts, which is basically not rendered. Which is basically font size, font key, and then we want to have the font data. I'm not sure how WebRender does this, but font, add font, raw font key by Q8, native font key, okay, add font, just search for font, glyph rasterizer, platform, add font, text run primitive CPU get font has font, clear font, delete font. This is actually interesting because we need to also delete the font key. Yeah, we can say, okay, deleting the image is pretty easy. Delete image. Just where we can say, okay, delete image. Remove image. Yeah, we can just say match images.self.entry.into. None if there no with some images, image state. Let some we don't actually need to have the images that get into. Yes, exactly. So in order to have this, we need to say resources, remove image, but vacant v the insert so this will also about to be deleted image key option image key, because we need to have the image key to delete it. Okay, so if you haven't even uploaded, we have this ready for, if this is ready for upload, we have the font data. If this is uploaded, font info to delete image GUI equals some, and then we get the font info. Oh, image info. Sorry. Image info. Image info key. And we have to make this mutable. So okay, then we want to say b.insert image state about to be deleted. About to be deleted. About to be deleted, and then to delete image GUI. Okay, and then yes, we deleted it. And else, yeah. So in the renderer, we can then also say in the display list, we can say, okay, update resources. First we want to say first we want to say image state about to be deleted. And then here's the question, where do we actually put this? Resource updates, where's this delete? Exactly. So we just say delete image. Deleted images equals vec string. So we can't deleted images equals vec string new. About to be deleted. Vec string option image key new. Deleted images to push key. So delete images. Resource key, image key, resources dot delete image key if let some image key equals image key. Resources dot delete image key, and then updated images, yes, and then add resources dot images dot remove resource key. Really, where is the image state? About to be deleted. rfk.clone, because then we're just saying, okay, we can actually use take, technically, take, yeah, so that we don't accidentally, even if this wouldn't exist, the image wouldn't draw anymore. If you've deleted it, it would still exist, but here we move it out of the option and leave a none in the place. But hey, resources, so add font, images, so I'm not sure. Exactly. Image state uploaded. Match V. font enum hashmap vacant entry. Get, I think it's called, no, it's vacant entry. What's the function for getting the value out? The key part of the entry. Vacant entry. That should be. Yeah, I don't think this works. Some let to delete image key. Oh god. Sorry. Oh. Some so if we get match So does this actually work? Yeah, it seems to work. Remove image, delete image key, delete image key. I don't know why I have this font that some image queue resources delete image, app resources.image, remove this. So this should at least this doesn't do anything, but it should at least work. Font data. Font error, expected image error, yes, font error. Doesn't make sense to have a font error. Match if that's some background info uploaded, ready for upload, only if there's an upload, right? If we have about to be deleted, we don't push the image. So cannot borrow an anonymous field that, oh hell, it really doesn't need to be this way. So now we can remove images. So if we now say, okay, add font. Yes, it does. It will. It should still run. Yes. Okay, so this. So we can, yeah. So we now have the add font. Then we have the remove font. I'm going to take a break shortly. So we did clean up a lot of stuff around removing fonts. Now we are going to actually do the font rendering. So I'll be back in a minute. Yeah. Yeah, yeah. Alright, so let's now go about adding the actual fonts. So if we now add the fonts, vacant, we have v.insert, entry, vacant, font state ready for upload, self.fonts, font data, to end, and then we basically need to see what is the next step, what can we already do, because before oh, they actually replied. No, they didn't. Yeah, I need to unsubscribe from this one. So we just need to look at how does the we got images working. Now how do we add fonts? Text layout, layout text, font, glyph rects, before we do any glyphs, we first just want to we want to have the fonts. Fonts. Oh, another. Selected glyphs per line. Yeah, text layout. How does he actually get a font key? At font info. So this is font. This was this awful code, right? I mean, you can't really make this up. He tried to use these fonts from a predefined path. This is just awful. Load font, Rest type load font info, web render load font. Okay, first we want to say Rest type. Yeah, font. We need need to say, okay, Rust type is you don't want to use font. You don't want to use a free type for this kind of stuff if you can avoid it, because free type creates really just awful build problems on Windows. It's just like it's awful. If you can, come on. I'm still connected, am I? I may have some internet problems. No, I don't. Why is this so slow? I mean, I'm not downloading anything, so yeah, it's just my internet is just so awful. Rust type, and then we can say, okay, this is what I generally like about Rust, because you can just add these creates within like 3 font. Font. Now we want to get a font error. You never use stringified errors in return messages, because if someone wants to localize this error, right, and he only has this error of bad font format, you don't want to do this. You don't. Using strings as errors is always a bad idea. Into font, right, I have to see how I actually did this. Yeah, the streaming rate is currently awful. I don't know what's going on. I need to reset the router probably. I'll be back in a few minutes.